Welcome everyone to today's webinar, ERP Making Your Investment Work Using Advanced Scheduling. We've taken a screenshot of an example. Before we get started, I'd like to go over a few items so you know how to participate in today's event. We've taken a screenshot of an example of the attendees interface. You should see something that looks like this on your own computer desktop in the upper right corner. You are listening in using your computer speaker system by default. If you would prefer to join in over the phone, just select telephone in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenter by typing your questions into the question pane of the control panel. You may also send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. If you have any other questions regarding the audio, you can submit those as well in the question pane. I would now like to hand over the presentation to our moderator for the webinar, Blake Lucan.
Thank you. And hello, my name is Blake Lucan. I'm the Business Development Specialist for Advanced Planning and Scheduling at SNIC. And thank you to everyone who has joined us today. I'd like to start by introducing our speaker for today's webinar, Nikhil Joshi, founder of SNIC Solutions. SNIC Solutions is a smart expert partner of Siemens in North America and Asia with proven experience in advanced planning and scheduling. As the founder of SNIC, Nikhil is an experienced industrial and systems engineer having proven experience in implementing manufacturing operations technologies like advanced planning and scheduling and manufacturing execution systems across the globe. Nikhil is here today to share his experiences on the benefits of having an APS add-on to your ERP. Nikhil, over to you.
Thank you, Blake, and thank you everyone for your time here today. The last 2 decades have seen significant investments in ERP in the manufacturing industry, making it the system of record across industry sectors. Whether you have a best-in-class ERP, a homegrown ERP, or just financial packages like QuickBooks, demand uncertainty has brought in many challenges that unfortunately ERPs are not designed to handle today. I look forward to sharing what we have learned in the last 13 years, improving production planning and scheduling systems across the globe in more than 9 countries. We as SNIC Solutions have had the opportunity to help discrete industries like industrial machinery, automotive, and heavy equipment manufacturers, as well as batch manufacturing companies like food and beverage, packaging, and chemical manufacturers. What is interesting across these manufacturing spectrum is that while so many industries, the operations, the way you work differ all across the spectrum, production planning and scheduling problems are very common. The focus of this webinar is to cover the challenges faced by manufacturing teams today during demand uncertainty. We will then go ahead and look at the limitations of ERP and spreadsheets in resolving today's challenges, understand what is advanced scheduling thereafter, and also understand the benefits of adopting it as an add-on to your existing ERP systems. We'll also cover the impact of shop floor data collection, or as it is widely known today as manufacturing execution systems. So going started, let's begin with a small understanding is that the business challenges that are there today and across most manufacturing companies is that either manufacturing and supply chain teams are trying to say that how can we be on time better to our customers, how can we improve services to our customers, how we can look at reducing our costs further and maintain or improve our profitability by bringing down costs related to inventory, cash flow, working capital, etc. So if you see some of these various business outcomes as some of the challenges that you are also looking to address, let's jump today to understand how basically these challenges are linked to some of the business outcomes that I spoke about. Talking about the challenges, let's first get into a few scenarios. Let me come up with sales and operations. Every manufacturing company has sales teams, operations teams. And have you experienced sales teams frequently having to change their forecast or order priorities? If you're a production team member, have you experienced, grouping similar production orders, similar parts to efficiently run the plant because that's what you're supposed to do as part of your KRA? Interestingly, when we ask sales teams and customer service teams in some manufacturing companies, as they're called, as to how you handle such situations, the frequent response I have got is that, well, if my customer needs 100 units next month, I ask the operations team for 110 or 120. And when we have had innumerous number of interactions with the operations teams and ask them, how do you handle such challenges, the frequent response is that, well, if we make 100 units a week, and if we can make 100 units a week, we plan only based on being able to make 90 units a week and leave the rest 10 units for uncertainties, or if something goes wrong. And this kind of a challenge makes situations more complex. But let's go ahead and make the complexities a little more. Have you experienced purchase teams not being able to supply material on time, and by the time you have missed an opportunity in production to plan alternatives? Have you sometimes experienced operations, supply chain teams, and sales teams get into firefighting mode where everything does not go according to plan? If you're nodding and smiling as you think about these questions and scenarios, then I can only say that this webinar will be deeply insightful. You might be wondering as you look at the slide as to where is the production planning team in this above scenario? Well, I have to tell you that he's invisible, he or she, and right now because they are working hard to firefight better. But let us understand why the production planning teams are working so hard today. It was not the case before. It was not the case 10, 15 years back. So what has changed? If we go forward and understand what has changed, we need to understand the concept and the need that has come out in today's manufacturing shop floor situations because of the innumerous dynamics that have increased the production planning and scheduling departments to synchronize multiple activities better. Let's understand this with an example. Think of a manufacturing plant. Let's say if you're a discrete manufacturer, think of we having an assembly plant. You might be making cycles, cars, or just some equipment. And assembly requires machining, and machining requires casting. So you can see that unless I don't have my casting, I can't do machining, and unless I don't do my machining, I really cannot supply my parts. And this is very similar even to batch manufacturing companies, whether it's chemical manufacturers, whether it's food and beverage manufacturers, where the operation names just might be different, but there are dependencies. So if you see what happens is that when we talk about dependency, for me to go ahead and schedule my finished goods in assembly, I am dependent basically on operations that are local to the assembly, but at the same time there could be one remote operation that would be dependent basically on what the entire machining department does, and they themselves would have basically multiple number of operations or activities or tasks that they need to complete. And if you see that the machining might have one task which is dependent on casting coming either from a vendor or whether it is coming from your own internal plant. And if you see this dependency, once I get a synchronized feedback from the casting plant, I'm going back and forth and doing rescheduling. I'm again scheduling. I'm again going back to my assembly who's reconfirming. It's a very simple example of a shop floor which is trying to basically coordinate multiple dependencies. But in the same manner, you can see that it is also going ahead and looking at larger complexities that we talk when we talk about manufacturing, is that this kind of dynamic synchronization is not only required inside the plant, but it's also required across the cross-functional teams, whether it is sales, whether it is supply chain, whether it is operations, and production planning and scheduling teams are generally basically the key nervous system in coordinating with all these cross-functional teams, including the management teams, in terms of what actually has to be done. So if we talk about synchronization, we went ahead and spoke to decision makers, manufacturing decision makers, and we asked them that what are the industry pressures driving focus on demand-driven manufacturing? Because hey, unlike a couple of years ago, or if you talk 10, 20 years ago, demand was not very uncertain. You could predict what the customer wanted. But now, with the demand certainty increase, many manufacturers are moving to demand-driven manufacturing. And one of the industry pressures that we identified is that 50% executives mentioned that improving response to market demand was a key pressure and on top of their list. And as a response, more than 56% executives mentioned that synchronizing demand signals with operations is what they were doing or planning to do, or identifying solutions that could help them synchronize demand with operations, or as they say, manufacturing execution, to respond to the market pressures. ERP and spreadsheets, unfortunately, do not solve this. Let us now go forward and understand as to why is my own ERP that I have made significant investments into not really able to do advanced scheduling, and what could possibly be the limitations. So if you have a case where you're thinking right now that I remember my ERP having production planning modules and some scheduling capabilities, or if your internal teams have built some custom scheduling modules as an add-on to your ERP where it's homegrown, it's Access or spreadsheet based. If these are some of your thoughts in your mind right now, the limitations that I'm going to cover will give you some insights, to investigate and evaluate as to why ERP basically by design has some limitations for production scheduling. We often see manufacturing companies having an ERP not using their MRP. Do you have such a situation? Do you have a situation where manually you're generating production orders? You're not having a link between sales orders or demand in your ERP, as well as your production orders or your planned orders in your ERP because of multiple limitations. These are some of the questions or scenarios, if you have, we will cover basically as to why companies end up being in that situation after having made significant investments. So as we go forward, let's understand this with some animation and example. Managers and decision makers who are responsible for production scheduling are always deciding the right sequence in which orders have to be scheduled. If we look at what happens inside an ERP, let's take this box that you see, and let's say the ERP is considering my capacity. It's taking your plant capacity into account. And let's say one order comes in. So we fill the plant with the capacity, and we're using process time, setup time, or lead time as references. In this example that I'm showing you, the orange color is the process time or the cycle time. And if you see a small black bar on top of it, that's basically the setup or changeover times. As I start getting more orders, more demand, I start filling my capacity, and salespeople don't stop until the capacity is full, which is what they're supposed to do, and operations team go ahead very well and schedule or plan using the ERP. And once planning is done, everybody thinks that, yeah, all will be okay. But let's understand what actually happens in reality. So when scheduling teams in reality go ahead and sequence them is where we can realize and see how previous orders schedule uh, and how previous orders scheduling impacts the subsequent orders depending on various factory constraints. So if you are a manufacturer into discrete manufacturing, think of a situation of your printing machines or a paint booth, where it's not a standard changeover of 2 hours every time or 4 hours every time. There could be a difference. Sometimes setups could be 15 minutes. Sometimes they could go for 2 hours. If you're a batch manufacturer, think of constraints like koshers, allergens, or cleaning time of a tank when you change batches, especially when they're not the same products. All these factors affect sequencing and have to be considered to understand the true capacity being utilized. This is not all. Production teams and scheduling teams, they go one step forward, right? They know that orders would be late, if we planned this way, and also they need to go ahead and utilize capacity. So there needs basically some balance, and because there is a need of a balance, what happens is that if we go ahead and look at this example again, I again have the same orders coming in, and let's say these orders. But now instead of looking at it just as a plant level, let's look at a resource or a machine. Now on a particular machine, the things and scenarios also take a different shape. It's not only about sequencing, but it's also about capacity optimization. So if I look at this problem here, take A1, A2, A3, A4, A5, and A6 as different production orders. But let us say that this is the initial sequence, that is coming with respect to, the orders that have come in. But if you look at the colors there, orange are the same parts, the blue are the same parts, and the gray colors are the same parts. Now, this is where a lot of tribal knowledge as well as scheduling experience is used by production teams in any manufacturing facility. And they come up and try to say that, hey, what's the preferred sequence? Can I really take the blues together? Can I take, the oranges together, put them together, and see if I could utilize my capacity better and get an optimized or a better sequence and get some capacity gains? This kind of flexibility of doing these what ifs, what I can do, what I cannot, is one of the primary limitations that manufacturing operations and supply chains team face even after having made significant investments in ERP. Let's look at one more problem, and that problem is related to pegging, or we call it the MRP problem. One method to overcome the problem is to make the due date of producing orders the same as our earliest start dates. So whenever I have a due date, I say that that's the day it's going to start. That means I start production in the morning, I start production in the evening, and if that's the scenario, you're not going to see the pegging functionality have a lot of effect. But if you are a manufacturer where to produce a part or to produce a batch, it does not take basically just like 2 or 3 hours, or it just does not take 1 week, but takes days or sometimes weeks. Then you will see that this limitation can hit you very badly. So let's understand what this is. We'll take a simple example of I have an assembly, and I have the assembly needs a raw material that is coming from a vendor. But I also have internal departments where I'm doing subassembly 1 and subassembly 2. Now, as I go ahead and put a work order, so you can see this is a work order for the assembly. What the ERP is doing is that it's taking basically lead time into account, and then it's planning backwards. So it's saying that if assembly is scheduled in this manner, let me go ahead and schedule my work orders internally for my subassembly as well as my raw material. And you can see that this is a schedule that the MRP runs. And just for anybody who's not aware of MRP, it's material requirements planning in an ERP. It's part of the production module. You use your MRP module to understand when do I need materials in the plant. And this is a very good way to order materials. But this example is taking into account an assumption, and that assumption is that you have infinite capacity in your plant. That means if you have just 10 machines in your plant, your ERP might be thinking that you don't have 10, you have 20, 30, or even 100, so to speak. So what really happens, and why is basically their limited pegging functionality? So let's understand how these are going to connect with each other. So if you see, for the assembly to happen in the manufacturing, you need the subassembly to be completed, you need the subassembly 2 to be completed, and you also need to have the raw material from the vendor, and only then you can start assembly. But let's take a scenario where you went ahead and the subassembly 1 for some reason was delayed. Bob and Joe, who were supposed to do subassembly 1, did not make it because of flu. At this moment of time, you can see that it's an invalid schedule on your screen, and ideally the assembly should be pushed out, but the ERP has limitations in doing this. What actually should happen is, if you can see, the animation is that you need to move the work order to take the late arrivals into account and then push the assembly. This is one of the cases that we have seldom seen where production teams fail to basically get these outcomes from an ERP, and time and again they move to alternate scheduling systems, almost most of the time they being spreadsheets. Let's look at some more problems basically that occur. ERP has very good rough cut capacity planning, but rough cut capacity planning is not really scheduling, because capacity is usually considered in weekly and monthly buckets. There's not really a notion of sequencing, as we explained. There's no notion of constraints, and plans that are generated are really always not feasible. So there are a couple of ERPs that by design went ahead and incorporated lean manufacturing systems into their ERPs, which is a great thing to do. And lean, Heijunka, and Kanban capabilities have really been great techniques, promoted and moved from the Toyota production systems. But in a demand uncertain environment, these have limitations. If you see a Kanban, it's a pull system that triggers replenishment of materials based on buffer depletion. But what happens is that a Heijunka box uses customer Kanbans to visually smooth out production. So it's basically saying that, hey, I'm going to see, what is the forecast, what each customers need, and I'm going to make sure that enough number of products are available for me to deliver to them. Now, the Heijunka blends the customer Kanbans as well as stocking Kanbans to level production. Now, it's a great technique. A lot of people in the make-to-stock environments use it, but if you are a make-to-order or an engineer-to-order, if you have a lot of SKUs, too many product variations, and if you're a hybrid scenario, you're partially make-to-stock, partially make-to-order manufacturing company, then there are some limitations that come up. The number of Kanban cards, for example, are based on historical demand. So the assumption of a Kanban technique is that whatever has happened in history, the same thing is going to repeat in the future. Also, it's assuming that there must be enough capacity available to catch up if production falls behind. So it's assuming, again, in some or the other way, that you have infinite resources on the shop floor. Because Kanban sizes are not dynamic, you don't really have an inherent ability to self-correct. This self-correction limitations are also there in ERP's MRP modules, where when you define safety stocks or minimum order quantities, essentially these parameters are usually changing, and one needs to keep dynamically reviewing them and keep updating the masters. But we see that as some of the limitations. And for Heijunka to work properly, Kanban sizes must be just right. Otherwise, typically we see them failing. So with some of these limitations that I explained about the ERP, you can see that even after significant investments have been made by manufacturers across the world, today in the world of demand uncertainty, the situation is still looking more or less like what you see depicted by this cartoon. We're still working in sort of silos. There's not really great synchronization between sales, planning, and operations. So with this being said, let's understand in the next segment as to what are people falling back to. So once most manufacturing companies, when they have made significant investments in the ERP, it's very difficult to say that, hey, what do we do now to solve operational problems? And we've seen seldom, often when we talk to manufacturing companies, they have fallen to spreadsheets, for scheduling. So they would take, you would take master data from your ERP, bring demand from there, any routing data, etc. Sure, you can bring that from ERP, but actual scheduling is taking place in the spreadsheet. So in this section, let us understand that while most of the world uses spreadsheet for scheduling, from a demand uncertainty point of view, okay, what are the limitations? So when we talk about limitations, let's talk about a plan. So most spreadsheets are very good at making a plan at the start of a month. You could make very good plans for a day, come up with a Gantt chart that you can see on the screen, and really replicate and do a very good plan, especially if you're an experienced person. One really comes out with very accurate and very effective and very efficient plans. The problem with spreadsheets is that you can generate a plan at the start of the month, but the moment you have dynamics that come in, you have rush orders from customers, a machine went down on the shop floor, there was false data, or there was some quality rejections. The question basically that comes in everybody's mind in manufacturing today is that how do I reschedule with so many dynamics? So manufacturers need to see today, in a demand uncertainty environment, the impact of these dynamics problems on their schedule much before basically than they occur. More like saying that, hey, if I had known these problems earlier, I could have basically done something about it. So this is one of the key limitations of using a spreadsheet. The other limitations of using spreadsheets are that if you look at the screen, planning and scheduling as a function is linked to sales, operations, materials team, etc. And there are multiple objectives that are serving business outcomes. You would have material requirement planning, you could have work in progress inventory, and you could have demand leveling, sales order priority, sales versus dispatch visibility, production KPIs. Some of them would be taking decision to say, how much do I make in the plant? How much can I outsource? Labor, tools, overtime planning. And with spreadsheets, what happens is that all these objectives have their own spreadsheets. So different objectives are going ahead and having different objectives. And then you also basically, it's difficult to get one single version of truth due to lack of controls. It's very easy to hide errors and mistakes. We have seen many production meetings where everybody comes with their own spreadsheets, and the firefighting begins. Collaboration is limited. If you talk basically from the industry 4.0 or in the world of cyber physical systems where everything is getting connected, in the era of Facebook and Twitter, where you're instantly able to collaborate with people, spreadsheets basically limit your collaboration capabilities. And if you are there's no log of change, which in our opinion is one of the biggest limitations, because if there are errors, or if even if you want to identify that where did we go wrong, how can we improve, there's no log of change for you to act upon and make things better. And finally, spreadsheets scale very poorly. So if you're a multi-plant manufacturing facility, or within a plant, you have multiple departments, scaling scheduling systems basically become there are limitations when we talk about spreadsheets. So with all these being said, this webinar is to help you understand how can advanced scheduling be a good add-on to your ERP. You can evaluate as to why advanced scheduling can really solve some of the business outcomes we spoke about, some of the challenges that we spoke about. Let's get a little technical and let's understand what is advanced scheduling really and what it is providing. So advanced scheduling is nothing but production scheduling, but in form of or manufacturing scheduling, but in the form of basically an advanced scheduling system or a software which has basically a lot of scheduling rules or logics or algorithms. You may have heard of these different rules, or you may basically even be with your experience using these rules in some of manual form, whether it's going forward, known as forward scheduling, or backward scheduling, or you may schedule by resource, like whichever machine that you have. Then we have things like transfer quantity, as to starting the next operation while the previous operation is still running. And I'm sure you're going to be doing all these things, but there's going to be a lot of experience, tribal knowledge, and manual element involved. And finally, you would be basically following some sort of custom business logics as a manufacturing organization. An advanced scheduling system brings all this tribal knowledge experience into a system that can help you collaborate. Let's understand what an advanced scheduling brings. So think of a manufacturing facility, and let's say it has about 4 machines, and let's say we are producing these 3 types of products. It's a green, a pink color product, and a blue color product. You can see that the 10th operation can be done either on machine 1 or 2. The 20th operation can be done on machine 2 or 4. Then you have 30th, which can only be done on machine 3. And then the 40th operation, which can be done on machine 2 or 4. So as I basically go forward, when I bring in an order, you can see that I can go ahead and sequentially load activities in a forward manner, where I'm going and taking one order at a time and scheduling all its operations before I bring in the second order and before I bring in the third order. This is one way of scheduling. The other way of doing it is completely backward, where you're taking a due date and then you are deducting basically the buffers based on the cycle times, and then you're going and scheduling everything backwards. You also have basically another possibility to schedule is through resource selection. In this example, we will see that we will go operation by operation, take all the orders, and say that which resources can they go to. So you can see that it's only looking at operations 10 first, then it's basically looking at operations 20 first, and then it's looking and comparing operations 40, And as I do this, that's how basically it's going and sequencing it. So this is a resource selection algorithm. And as I go forward, bringing in, and you can see that the whole animation that you're seeing on the screen typically happens in the minds of production teams or anybody who's an experienced user using the spreadsheet. But the spreadsheet actually cannot really do this, and even ERP has limitations in giving you such flexibilities. So let's make it a little more complex, where we're looking at the transfer quantity. So think of a batch manufacturing scenario. You can see here that the first green order has short operations that may not really need to have the make span reduced or the lead time reduced. But if you see the next operation, when I bring in the pink orders, you can see that the 20th and the 30th operation is a very long cycle time. So it's like running basically, 100 units for the next 3 days. But if the machine is already pumping out, 50 units as a batch, maybe I could move that batch forward and start the next operation. So ideally, you want the transfer quantity to actually help you and schedule the 30th operation earlier so that you can have a reduced lead time. Manufacturers are doing this time and again, and essentially an advanced scheduling system provides flexibility to do this automatically and very quickly. Let's make the problems a little more complex. Flexibility and choice is what you get with an advanced scheduling add-on. So let's take this particular example where each number that you see on your screen is a date. Like this is this order. Each box is an order. You require this order on day 1, then you require this order on day 2. Again, this white color is required on day 2, and so forth. And the different colors represent that they are different parts. Now, the first scenario that I've shown on the screen is straight away just going ahead and scheduling everything, just according to the due date. But now if I go ahead and do some capacity optimization with some set of changeover algorithms, then you can see that if I'm just looking 2 days ahead, I can bring the second order, the second white order together. So it does reduce the make span, it does reduce the lead time, but you can see that the pink color order here is actually getting delayed. But it's certainly better than the previous one, because in the previous scenario, 2 orders were getting delayed. But when I do some optimization, I'm seeing only 1 order being delayed. But now, production team might be say, hey, changing and reducing changeover is a good thing. So let me go ahead and look ahead further, to 3 days. And while I'm getting an optimum changeover reduction time or a very good capacity utilization, you can see that I'm also having 2 orders being delayed. Now, the flexibility to understand the impact of what you just did is what an advanced scheduling system provides. Moving forward, it's not only the flexibility with respect to the setup time and the changeovers that I showed, but advanced scheduling systems are capable of taking into account equipment availability. You might be running machines in 3 shifts, sometimes in 2 shifts. You might have labor availability. Bob and Joe this week are only working for 4 hours, and from next week they're going to be again working for the regular 8 hours per shift. Tooling constraints, power constraints, multiple constraints can be taken into account when we are looking at scheduling. So with these advanced scheduling advantages, what we are talking about is not replacing the ERP, but we are talking of enabling the ERP and making your investment much more effective with the add-on. So let's understand very quickly, how does an advanced scheduling system work alongside in synchronization with an ERP. The ERP is no doubt the system of record, and you can go forward and maintain it as a system of record where you store your master data like routings, bill of materials, your cycle times, your item masters, and you would then have transactional data like sales orders, purchase orders, production orders. All this basically become your transactional data, including stock, the existing stock that you have. An advanced scheduling software or a system brings this master data and transactional data into this advanced scheduling system, and then you basically apply the different constraints that we just spoke about, the different algorithms, the different, the different flexibilities that you need. And as you basically, as you basically go ahead and look at these constraints, you can have the schedule jobs that come out as an outcome. You can also add primary calendars, secondary calendars, where you're running some machines in 1 shift, some machine in 3 shifts. You can put all those constraints and then come out with accurate schedules, which can then be sent back to the ERP for the sales team to look at, when are they going to actually be able to deliver to their customer. Now, this is a small snapshot, but with our 13 plus years of experience, we've also seen some of the best practices as to how advanced scheduling integrates with the ERP, the MRP, and the MES, where if you see a planned order that is generated in a ERP environment comes into an advanced scheduling system with inaccurate dates, you can send them back with accurate dates, generate production orders further back in your ERP system, bring basically back to them in an advanced scheduling module, and then send back again production dates against the production orders. And you can keep doing this to improve synchronization. And then you also take shop floor feedback, to reschedule. But in a sense, the ERP, which is the system of record, is responsible for material planning, inventory status, finance, costing, capex. This is what ERPs are designed for. Scheduling systems are designed to visualize production plans, predict what is going to go wrong, automate operational excellence, and run what ifs. And manufacturing execution systems or shop floor data collection systems are designed for tracking, traceability, quality traceability, genealogy, and plan versus actuals. So with this and getting an understanding of how advanced scheduling works with the ERP, we also should not forget the impact of real-time data from the shop floor. And we call this as shop floor feedback. You can call it as manufacturing execution systems, as it is popularly known as today. But essentially, it's taking what happened today in my manufacturing facility and feeding it back to my schedules. So let's understand that how this feedback, causes some limitations when we think about an ERP, or when we think especially about spreadsheets. I'd like to explain this example with most of you would have known about some years back. All of you would be using the GPS that your car rental provider would give you, or you would have bought one for yourself. But the old GPS systems basically had the capability to give a map, and it could tell you that it takes 4.5 hours to go from Chicago to Detroit. And if you're planning to start at 8 in the morning, it tells you that you're going to reach there by 12:30, just half past noon. And it gives you the route in terms of what route you should take. But the problem with the GPS was that we could not really predict everything. We could not predict traffic. We could not predict what's happening on, if there were road constructions going on. And think of the same analogy in terms of our shop floor. When things go wrong, what is happening on your shop floor? So if feedback is given from the shop floor, things like Google Maps, if you take today's Google Maps or Apple Maps, okay, even before you start at Chicago, it is telling you that you might be basically having traffic, after an hour, and chances are that you are going to be 30 minutes delayed. So this kind of feedback is really important for scheduling systems to be effective, to provide alignment, visibility, and coordination. Real-time scheduling actually can become a real competitive differentiator. We have seen many best-in-class manufacturing companies get a strategic advantage when they are using an advanced scheduling system and a manufacturing execution system on the shop floor in synchronization. And if you see, that the most successful companies are those that are using advanced scheduling softwares today. And what they're doing is that they're connecting the ERP to the advanced scheduling add-on, doing sequences, and then feeding that data to an MES or a SCADA system on the shop floor, which is being executed, and that updates are coming back to the scheduling system for rescheduling. And the biggest advantage of this kind of tight integration allows to monitor the state of execution against plan and real one single truth and visibility of the entire factory. So to summarize, let's understand the benefits of advanced scheduling. The production scheduling, as per McKinsey, in this slide, said that it directly affects all your performance value drivers, whether it is asset utilization, like your capacity utilization, whether it is quality, time to market, customer service, inventory, labor. It impacts basically all these value drivers. Um, Advanced scheduling has been around for a long time, and its adoption rates have significantly increased in the last few years. But best-in-class companies who've been using advanced scheduling today with their ERP or their MES, we have seen business improvements and benefits in 4 to 5 major areas. So we have seen either outcomes in terms of improvement in productivity or cycle time reduction or lead time reductions. We have seen inventory reductions. Typically, either they are work in progress inventory or they could be raw material inventory reductions. But the biggest impact that we have seen with the adoption of advanced scheduling systems is to response to market demand, which essentially leads to either increase in sales or improvement in customer service. And that is, manufacturing companies using such solutions have been very big beneficiaries in this area. So with this, I come to the conclusion of my thoughts and the learnings that I wanted to share. I really thank you for your time, and over to you, Blake.
All right, wow, thank you, Nikhil, for all those great insights and all the intricacies of advanced scheduling. And we're going to open up a Q&A here, but before we do, I'd like to thank our sponsor, Siemens, for the webinar today. Siemens Ops Center Planning and Ops Center Scheduling are great tools to help achieve a lot of the benefits that we discussed here today. If you're interested in learning more, we will be covering industry-wide use cases at Siemens offices in Toronto, Chicago, and Dallas on the dates you can see on the screen. We invite you to bring your team to join us at these sessions, and you can learn more about these events on our website, snicsolutions.com, or the link that you can see on the screen. So now I'd like to open up the Q&A. We'll go ahead and get started. So, Nikhil, the first question we have here, we have a lot of customer requirements, and we have to adhere to due dates. While we want to honor those due dates, we still want to be efficient. Would advanced scheduling help us achieve this?
Yeah, absolutely. So some of the advanced scheduling rules that I showed, in the interest of time, I did not show custom and configurable rules, but think of the changeover setup time rule that I was showing you, or the transfer quantity rule. The business case and the question that you asked is very similar. Many companies want to say that, hey, I want to go ahead and schedule everything by due date, but if I have opportunities to utilize my capacity better, not without an impact to the due dates, I'd like that to happen, and I'd like to do that iterations and understand if I could have a balance between capacity utilization as well as customer delivery. And advanced scheduling has a very large impact in doing that faster and quicker, Blake.
Great, thank you. The next question we have here is, you have used the term advanced scheduling throughout this webinar. Is that the same thing as production scheduling or supply chain scheduling?
Yeah, absolutely. Generally, you have production planning and scheduling departments who are really responsible for sequencing. So what's going to happen today in the first shift, second shift. Many people call it production planning. Some people call it production scheduling. Some of them call it manufacturing scheduling, sequencing. All these are synonyms of advanced scheduling. It's just that advanced scheduling refers to basically using software versus doing it all manually.
Sure. One more question we have here. We've already invested in our ERP, but realized we need an add-on. How do we do a business justification for our leadership team given the investments we've already made?
Well, you can call us. Well, okay, like the joke aside, typically a business justification in the kind of scenario that you mentioned, that's actually a very great question, and it's actually needed. I would suggest focus on the business outcomes. Typically, chief financial officers or C-level executives are looking at either reducing cost or improving profitability or improving sales. So if you go ahead and improve, let's say, on-time delivery, let's say you're at 90%, and if you go from 90 to 95 or 100%, you're doing more sales in the same month than what you would have done before. I urge you to look at some of the case studies, or one of our case studies on the Siemens website, where the customer actually increased sales revenue by 10% using advanced scheduling. That's one area. The other area is basically more towards cost reductions, where if you by design you can produce in the plant, let's say 1,000 units a month, but for some reason you're only manufacturing and producing 700 or 800. There is a gap there that can be filled, and the scheduling algorithms that I spoke about could actually help you to go ahead and improve your capacity utilization, which would have a direct impact not only on sales but also on the costs, be it energy cost, be it the time you spend, the people you deploy, all those areas, basically the saving. And the third area is inventory, Blake. We see, especially in batch manufacturing, when you are working with so many different SKUs, so many product mix and product variants, it's very difficult to know where the work in progress inventory is building up, and that has a direct impact on the cash requirements to run the business, or as it is like, it's like the working capital that is required. So inventory reduction has direct impact on working capital, and that's an area that could be looked for business justification for bringing on an advanced scheduling system. But if all these three areas, like, you are, best in class, doing it really well, then the only fourth area that I could look at is that, to really, if you're achieving all those objectives, you need to ask a question: at what cost? Am I spending hours and hours, in planning meetings, running our planning meetings, or having large planning teams to look at what needs to be done, or can I basically look at reducing my planning cycle, whereas we are not firefighting, but we are being predictive, and we are focusing on the main activity, which is to coordinate with multiple departments and make sure things are in place. What we see many times planning teams is that they end up spending a lot more time firefighting rather than doing prediction, and any time reduction there would lead to direct savings, Blake. So these are the different business justification opportunities.
Great, thank you for that explanation. That looks like that's all the questions we have today, so thank you, Nikhil, for your time again, and thank you everyone else.
Thank you, Blake, and thank you everyone for attending today's webinar. If you have any other questions, please contact blake.lucan@snicsolutions.com. Once you leave today's webinar, you will receive a survey on the presentation, And we would appreciate if you would complete that and provide your feedback. You will also receive a follow-up email within 24 to 48 hours with the link to view a recording of today's webinar. On behalf of SNIC Solutions and our presenters, thank you for joining us today and have a great rest of your day.